Okay, topic is natural gas system. General, natural gas is primarily composed of methane with minor percentages of other gases that result in variations in heating content. So there are several types of service that a utility company may provide, each with a different cost or rate. We have firm service, constant, interruptible service, light or heavy process service, commercial or industrial service, and transportation gas service. Ito yung deliver ka lang. Itong iba ay yung may mga piping. Wait Okay, ito na animation. So natural gas is usually obtained from franchise public utility, parang water district, diba? Obligated to provide gas to every customer that requests the service. As part of this service, the utility company usually supplies and installs the service line free of charge from the utility main, in addition to providing a regulator meter assembly in or adjacent to the building. Punta tayo sa firm service. This type of service provides a constant supply of gas under all conditions without exception. This service has the highest rate. Next is the interruptible service. This type of service allows the utility company to stop the gas supply to the facility under predetermined condition and then to start it again when these conditions no longer exist. The most common conditions usually occur when the outside temperature falls below a certain point. So the rate is lower than for firm gas, and users with this service will require a backup source of fuel such as fuel oil or LPG. Light or heavy process service. This type of service is provided for industrial or process use and is reserved for quantities of gas that the utility company defines for this class of service. Next is the commercial or industrial service. This type of service is provided for heating and cooling system load for this class of building usage. Transportation gas service. This service is purchased directly from a company other than public utility, with the gas actually carried to the site by the utility company pays. In addition to the cost of the gas, the utility company will also charge an additional fee for this service. This type of service is always available. Ito yung mga critical information obtained in writing from the public utility. Hihingin po doon. The British thermal unit content of the gas provided, the minimum pressure of the gas at the outlet of the meter, nagaling sa ating company yun, utility company, the extent of the installation work done by the utility company, and the point of connection by the facility construction contractor. The location of the utility supply main and the proposed run of pipe on the site by the utility company. Sa site sa labas ng building mo yun. The acceptable location of the meter and or regulator assembly, and any work required by the owner to allow the assembly to be installed, such as a big meter pit, dug, or slab installed on grade. So the types of service available and the cost of each. Yung type of service. Confirm, occasional, okay? Ito naman yung mga information to be provided to utility company galing sa iyo, sa kliyente. What is the total connected load? The utility will use their own diversity factor to calculate the size of the service line. If the design engineer is responsible for the installation, this information is not required since the diversity factor for the facility shall be used. So the minimum and maximum pressure requirement for the most demanding service, yun sa kailangan nyo. So the site plan indicated the location of proposed building on the site and the specific area of the building where the proposed NG service will enter the building. Sige, ba? Yung site plan, andun yung building mo. Prepared location of meter regulator assembly. Expected date for the start of construction. Ito yung mga major natural gas system component. Meron tayong drip pads, gas line filter, gas meter, and pressure regulator. Drip pads are necessary to remove water that is in the mains from reaching the building. Okay. So mga drainage yan. The modern technology has reduced but not eliminated the presence of moisture in the utility company mains. Each utility company has a standard method of installing drip pads depending on pressure in the main. Next, yung gas line filter. Ayan. Filter for natural gas are installed at the site service to protect the regulator and meter from injury due to particulate logging, which may damage the equipment inside the building. Ayan. Sa site yan, sa site. Alabas pa ng building mo. Gas meter. Yan. Siya kasi sigilin. Yung mga gas meter, LPG, natural gas at LPG, ganyan yung tsura. Regulator. Gas meter are part of service assembly that may consist of filters, valves, regulator, and the lid valves. The complete assembly is usually supplied and installed by the utility company. For the rare instances where this is not the case, gas meter are selected using the local utility company standards with the size and arrangement of the entire meter assembly based on flow rate and pressure. Because steady pressure is necessary for accurate metering, a regulator is installed upstream of the meter. Next, pressure regulator. Gas pressure regulator are pressure reducing devices used to reduce a variable high inlet pressure to a constant lower outlet pressure. Two types of regulators are available, the direct acting and the pilot operated. The direct operated type uses the difference of pressure between the high and regulated side of the regulator to directly move a closure, adjusting member using the regulator to adjust the pressure. The pilot operated type uses a primary regulator to sense and magnify differences in pressure of high and low pressure sides and a second main valve with the closure member to achieve the desired pressure. Yung several categories of regulators. Meron tayong line regulator, which is used to reduce high pressure open in the range of 25 to 50 psi gauge, 170 to 345 kilopascal of the gas service provided by the utility company to a lower pressure used for the building service. Ayan, yung connection mo doon. Sa site, sa labas, then sa loob ng building, ayan, meron kang regulator. So intermediate regulator is used to reduce the lower pressure of it in the range of 3 to 5 psi gauge, 21 to 35 kilopascal to a pressure required to supply terminal equipment such as boiler, gas train. So yan ang papunta sa equipment mo. Appliance regulator used at the individual piece of equipment for final pressure. Nakikita nyo yung mga regulator sa tangke yun. Tutuan. Kaso LPG yun. Meron din gas. Line regulator. The line regulator is usually pilot operated and provided with an internal or external relief valve. The regulator is pressure rated to withstand the highest pressure expected. Intermediate regulator. An intermediate regulator is used within a facility where high pressure used for distribution purposes must be reduced to a lower pressure required by the terminal appliances. Next, the appliance regulator. The appliance regulator is used to control the pressure of gas directly connected to the terminal appliance or equipment. The appliance regulator is most often provided by the manufacturer as part of the equipment gas train. The gas train is an assembly of piping, valves, regulator, relief vents, etc. used to directly connect to gas supply to the terminal equipment. Another type of appliance regulator is called an atmospheric regulator or zero governor. This type of regulator is a very sensitive type that works with a very low gas pressure and extremely small differential. So differential regulator is a multiple port type that is used to produce a single uniform outlet pressure when supplied with multiple inlet of different pressures. Then back pressure regulator is a regulator arranged to provide accurate inlet pressure control. It is used as a relief valve where the application requires a higher degree of regulation and sensitivity than possible with standard puppet type relief valve. Pipe gas vent. So, ibig sabihin may piping ka. A pipe gas vent must be provided from regulators to a point several feet above the roof of any adjacent structure. And if it must be properly sized to carry the amount of gas that will be discharged. So this is to protect the system from overpressure in the event of malfunction or failure to fully lock up. Okay? Sa PCMA code natin, yung bago, meron ng gas vents. So each individual regulator vent must be separately carried to a non-hazardous location away from the potential source of ignition. So, ano mo siya i-release. Common vent lines are not permitted sa individual. So, regulator selection consideration. It is common practice to oversize the capacity of a regulator by about 15% to provide a margin for accurate regulation. For large loads, regulators in parallel are often used to keep the pressure drop to a minimum. The adjustment range of a regulator should be approximately 50% over the desired regulated pressure to 50% under that pressure. For example, 10 PSI, so meron kang 5 to 15 na range. Yeah. So the utility company may require that regulators be of the lockout type. This picture will stop regulator operation when the pressure falls below a predetermined set point. Site distribution. Okay, from gas utility company o pag-power up at uptex yung electrical wire mo, yung ibig sabihin nito papunta sa bahay mo. Hindi sa loob, site pa lang. So the site distribution portion of the system starts at the property line of the customer and usually ends above grade or concrete pad at the valve after the meter. The connection to the utility company mains are done by utility company. Polyethylene, tapos dito na yung pipe mo, BI, yung steel pipe mo. Ito kasi band underground, kaya plastic. The most often used piping material is a high-density polyethylene, STPE. So the rating for pipe 4-inch and smaller should be SDR11, parang schedule number 2. And for 5-inch and larger, SDR 13.5, check nyo lang sa internet to. The pipe shall be buried a minimum of 3 feet below ground and 14 AWG corrosion-resistant tracer while placed in the pipe trench and over the pipe. So para malagay sa mga place na mayroong gas line doon. So another detection method is to put a warning tape containing metallic material with the words natural gas on it. This is to allow location by a metal detector and to one of the gas line immediately below the tape if digging has taken place without trying to locate the pipe beforehand. The pipe above ground shall be metal. Therefore, a transition fitting is required if STPE is used for supply service. So ito yung connection. Okay. Then testing and forging. After the installation of the pipe is complete, the site system shall be tested, purged of air, and then filled with natural gas. The testing phase shall be done with compressed air, at a gauge pressure 50% higher than the highest pressure expected in the main. So, di ba, lahat ng testing is 50% of the pressure. So, hindi yung sabihin lang na 200 psi, 500 psi, may mga case na ito ang sa system mo. The larger the total volume of the pipe, the longer the test shall last. So, no loss of pressure shall be allowed. The test period is based on the size of the line and the length of the run. So, table 1 gives the recommended test period. So, yan. The minimum length of pipe, dito. The maximum length being tested. So, bawa 4 inches. Ang length mo is 2,000 meters. So, dito ka. In between yan, mga 5 hours. Isang itetest ng walang leak. After successful testing, the line shall be purged of air with dry nitrogen. The reason for this is to prevent flammable mixture of gas and air when the pipe is filled with natural gas for the first time. Okay, ma-replace mo sa pag-washing. Calculate the volume of the piping and introduce an equal volume of nitrogen into the pipe. After the nitrogen forms, natural gas is then introduced until the nitrogen is displaced and left under pressure. Now, for pressure drop. The pressure in the main provided by the utility company and the flow rate is the basis for design. So the line is sized using proprietary charts for the specific pressure in the gas main, table or charts. If the charts are not available, compress and friction loss table using table having the actual pressure in the gas service main can be used. Meron tayo dyan later. This will provide sizing within a range acceptable for the system. So the pressure drop selected is at the discretion of the design professional, but is generally kept to approximately 10% of the available pressure in PSI gauge. Bawal. With the PSI, so pressure drop was 2. Lalabas siya 18. Yeah? So to use the pressure loss table, calculate the pressure drop per 100 feet of pipe. So the maximum allowable system operating pressure of the fuel gas when installed inside the building is governed by NFPA 54, unless local code or insurance carrier have more stringent requirement. Natural gas system are not permitted to exceed 5 PSI gauge unless all the following conditions are met inside. So local authorities permit a higher pressure, all piping is welded. If the design engineer is responsible for sizing the meter and regulator, the following information must be calculated or established. We have the adjusted maximum flow rate in CFM for all connected equipment in the facility. Typical BTU values for equipment are given in table 2. Meron tayong table 2 dito. Yan. Yung mga BTU ng equipment mo. No cooking equipment. CFS demand for multiple buildings are given in figure 2 for 50 apartments and less, in figure 3 for more than 50 apartments. So ito. Ginagamit to pag wala kang input dito. Okay? So per apartment, nag-estimate ka ngayon wala kang interior design pa. Ito pag meron. Okay. The highest required pressure for the most demanding equipment inside the building. So ito yung kailangan mo rin doon. The pressure in the building service main upstream immediately downstream of the regulator. If a pressure loss to a filter is expected, this will reduce the pressure. Okay, kasi kailangan mo kasi yung meter and regulator. Ano i-regulate mo? Dalawang pressure sa inside at sa outside. Upstream and downstream. Now, the allowable pressure loss for the piping inside the facility. Ano yun? Ibigay mo rin. So the pressure differential between the service main pressure and the pressure required inside the building. This is the sum of items 2 and 4 subtracted from item 3. Ito yung 1, 2, 3, 4, 5, 6. So item 2 and the sums of item 2 and 4 subtracted from item 3. Number 6, the regulator meter and meter can now be sized using literature and catalog information from the manufacturer. So search. Yeah. The feeding chamba. Yung mga reference niya ng catalog. So, ito yung question draft, ito yung PUT for more than 50 apartments. So, next is the maximum probable demand. For types of building, such as multiple buildings and laboratories, the total connected load is not used to design the piping system, since not all of the connected devices will be used at the same time. For design purposes, it will be necessary to apply a diversity factor to reduce the total connected load when calculating the maximum probable demand. For laboratories, ang dinitest natin is yung papasok pa lang sa building. For laboratories, use figure of 5 CFH cubic feet per hour based on the use of Bunsen burner. Refer to table 3 for diversity factor. So ito, 1 to 5 outlets. Ito yung diversity. Ito yung average, ito yung maximum. Okay. For industrial or process installation and for major gas using equipment such as boilers and water heaters in all building types, no diversity factor is used because it is possible for all connected equipment of this nature to be used at the same time. Mga boiler, kasi industrial processes and continuous. Mm. Mm. Yeah. Okay, balikan natin itong naka-animate kanina. So this calculation first requires the listing of every device using gas in the building and the demand in BTU per hour for each. So the manufacturer of each device should be consulted to find each actual input gas consumption. Average gas demand values for typical devices are also listed in table 2. Pag wala, di available sa manufacturer. For drillings, a direct reading of the quantity of gas based on the number of apartments is presented in figure 2. Yan, up to 50. So, okay. Basta pala. Yan. Doon, sa figure na yun, figure 2 and 3, pero na doon diversity factor. So yun. So next, natural gas site service pipe sizing method. So from utility to the building, outside the building. So ito yung pipe sizing niya. The most conservative method for sizing NG piping system is by the use of tables, such as those prepared by American Society of Plumbing Engineers, ASPE. So meron din dito sa NFA 54. Okay. Tables are provided that will allow sizing for majority of system. Table 4 is for 10 PSI gauge. Table 5 is for 20 PSI gauge. Table 6 is for pressure of 50 PSI gauge. So, table 4 for 10 PSI initial gas pressure. Then 10% is 1 PSI gauge pressure loss. So, dito ka, may i-discuss ka na lang. Kung ang length mo, ito, ang consumption mo, hanapin mo dito. 90 feet. 2,000. So, ito na gagamitin mong 2854. That is 1 in 1/4 ang pipe size mo. Pag 3,000, so, 100 feet, 3,000, so dito ka, so 1 in 1/4. Okay? Huwag mo nang interpolate. Kasi pipe size yan, standard. Same dito sa 20 PSI, 2 PSI gauge pressure loss. Ganun din. Always next size. 50 PSI gauge and 5 PSI. So, mataas ang pressure niya doon niya sa labas ng building. So, okay? If higher pressure is encountered, the use of compressed air table can be used for sizing. So, reducing the flow rate based on a factor found in table 7 using the specific gravity of air, which is 1.0. So, pwede ka naman ng compression table. Table 7. So, ito, multiplier. Multiplier to be used for the specific gravity is different from 0.6. 0.6 is 1. Ang specific gravity mo ng compressor mo is ito. 1.0. So 0.78 ang multiplier. Later na. So ito yung sa labas. Then interior, sa loob na, ito na yung kailangan dito yung mechanical nila. So in order to size the piping system inside of any facility, the following information must be calculated or established. So the minimum gas pressure available from the utility company, the allowable pressure loss for gas flowing to the piping system, the equivalent length of the piping system, so layout mo, the maximum probable demand, the pipe sizing method acceptable to local codes. Kasi minsan, natanong yung, ano po sa size ng pipe natin? Ganito ka area. Ang layo nun. Ang layo, walang connection. Kailangan mo yung mga equipment mo. So, pressure available from the utility company. So, the minimum pressure that the utility company will guarantee after the meter assembly must be provided upon request. And it is based on the pressure available and the utility supply rate adjacent to the facility under design. In cases where the utility is not providing the meter, the minimum pressure will be given for the main at the tie-in point. So if there is a specific requirement for equipment that needs a higher pressure, such as that for boiler, the utility company must be advised of this requirement and guarantee this pressure in writing. So if higher pressure is not possible, a gas booster will be necessary. Booster, parang pump. Then, what is the allowable friction loss in piping system? So the minimum guaranteed pressure supplied by the utility company after the meter regulator assembly could be as low as 4 to 7 inch of water column. Mababa doon sa 50 PSI, 20 PSI. So this amount of pressure is quite low and requires that the friction loss of AG natural gas through the piping system be kept low in order to have sufficient pressure to properly operate the terminal appliance or equipment. Then, animation na naman. A range of values between 0.2 and 0.5 inch water column are generally acceptable, depending on the actual range of pressure available. When the available pressure is higher than 7-inch water column, a higher pressure loss is allowed for economy of pipe sizing, depending on the end-use pressure requirements. This is the pressure tab. Yeah. So equivalent length of piping. The equivalent length of piping is required to calculate the friction loss in all portions of the piping network. It is common practice not to use the vertical length of piping when calculating the total run for the natural gas system. So lahat ng pang-vertical, huwag mo nang isasama. Dito lang sa gas, natural gas. Yan. Kasi gas to. Iba yung LPG kasi LPG liquid, liquefied. Okay. The additional pressure sa LPG kasama. Ito hindi. So, since natural gas is lighter than air, it expands at the rate of 0.1 inch water column for every 15 feet elevation of as the gas rises. So, the additional pressure created as the gas rises approximate the pressure loss to friction inside the pipe. So, kaya zero. So, refer to table 8 for equivalent length of fittings and valves for the flow of gas in pipeline. So, ito yung ang papasok ito is gas. Yung mga fittings, equivalent length. Ito na kayo ng best ano dyan. Ito, fittings. Global, gate valve, angle valve, swing check pa. Next, sizing method. So, inside building, the most conservative method for sizing natural gas system is by the use of tables, such as those prepared by American Gas Association, which are included in Appendix C of National Fuel Code, National Fuel Gas Code, NFA 54. Table 9 is provided to allow sizing for low pressure system up to 1 PSI or 3.1 kilopascal. Table 9. Table 9. Ito yung table 9. Ito yung gagamitin natin sa sample natin sa pagsasamit nyo. Okay. To use the low pressure chart, first establish the acceptable friction loss in order to select the proper table. This is 0.5 PSI using this pressure of 0.3 inch based on 0.6. Yan. Then calculate the equivalent length of pipe from the outlet of the meter of regulator or point of connection to the farthest point of use. This is the only distance used. Yan. Sabi yung longest, yun ang gagamitin mo distance. Then, sabi dito. Ayan. Itong leg na to, yung pinakamalayo, yun ang gamit mo. So, itong column na ang gagamitin mo. So, magbabari ka na lang ng pipe size based dito sa flow rate. Okay. This is cubic feet per hour. Yeah. So, find the pipe size at the intersection of the above distant column with CFH figure that equals or exceeds the calculated CFH figure at its design point. Yeah. Pag 65 ka, use 70. Okay? Hindi ka huwag ka na interpolate. Yeah. Tapos, panapin mo dito yung compute mo is 40. So, dito ka sa 43. So, nung form mo is 1 half yung pipe size mo. Okay? Pag 500, so dito, kung 370, kung 70 feet yung ano pala, so 500, so 560 ka, 1 in 1 half yung pipe size mo. Okay? Yeah. Branches are sized using the same distance column but with CFS figure from the branch to connection with main. So, yung sabi niya, isang length lang, pati yung mga branches mo, so flow rate lang ng branch kukunin mo, wag na yung length. So, yun, as per dito sa instruction. Gusto mo makatipid, actually, pwede rin yun. Nagumamit ka ng iba-ibang length. Pero mostly, for the safety side, is yun na, ginagamit mo yung maximum. So, if a gas fuel with a different specific gravity is being used, the multiplier found in table 7 can be used to adjust the capacity found in table 9. So, yung ano yung sa table 9, multiply mo yung factor. Diba? So, na-compute mo, so, kung ang given mo is 10 cubic feet per hour, so i-divide mo ng factor. Hanapin mo sa table 9. Okay? Refer to table 10 for conversion of gas pressure designation. Yan, conversion lang yan. Okay? So, for safety, pwede kang gamitin. Yun na yung distance mo. Maximum. Minimum is pwede rin yung branch. Okay? Kasi para makakuha ng size na mas maliit. Allow din yun. So, pipe and system materials. All the piping materials must be listed in any P54. Ito ako ng pag-print ng P54. And other applicable codes. The most often used material for underground lines are high-density polyethylene, PE. For larger lines and high-pressure piping, the most often used material is steel pipe, protected against corrosion by wrapping with plastic coating. Codes do not permit plastic pipe to be run above ground. For above ground lines, the piping and jointing method depends on the size and system pressure. For piping up to 3 PSI gauge, 21 kilopascal, black steel ES10 A53 pipe is used with cast or malleable iron screwed fittings in sizes of 3 inches 75 mm and smaller and butt welded for joints of 4 inches and larger. For natural gas is considered dry gas, the type G ASTM B87 copper pipe is finding widespread use. I guess. It is available in sizes up to may nawawala. Okay. All piping for pressures over 3 psi gauge, 21 kilopascal, shall be made of steel with welded joints. Welded fitting shall conform to ANSI 16.9. Screwed fitting shall be made of black malleable iron, 150 pounds, conforming to ANSI A 197. Check valves shall be cast iron, 306 stainless steel trim, this type with a soft sheet. In sizes of 3 inches and smaller, use screw joints. In larger sizes, use flange joints. So this is the properties of natural gas. Formula CS14, mostly acidic, molecular weight, melting point, boiling point, specific gravity is 0.6. Gas, specific gravity of liquid is 0.3. Water, based on water. Ito based on air. Okay. So latent heat of specific gravity of gas, 2.6. Ito, pero, ano siya, base ito sa weight ng air. Okay? Ito, base ito sa weight of water. So latent heat of vaporization at mga boiling point, 2.5. Vapor pressure, ito, kailangan natin ito, gallons per pound of liquid. So, magkikawa ko yung ilang gallons. BTU per pound of gas, heating value yan, 15,000. Ito BTU, ito gamit na 1,050 BTU per gallons of gas. Kasi given yung BTU mo, i-divide natin ito, makuha natin yung gallons per hour. Diba? So ito yung cubic feet of gas, temperature yun. Wait. Okay, tama. Ito, BTU per cubic feet gas, 60. Yan. 1,050 or 1 plus or minus. So, pwede tayo mag 1,000. Okay? Average. 1,000 cubic feet per pound. BTU per cubic foot. So, yan. Ito sa example, design a gas piping system shown. So, ito yung layout mo. Nag-layout ka. Ito, diagram. Ito na gamitan. Mga length. Ayan. May distansya. Ito yung section 1. Ang pula dito is ito yung outlet A. Given na yung ano. Ginagay na natin. Based sa table. 30,000 BTU per hour. This is 60 feet from mamaya na yan. So naman, outlet B, gas lang lighter, 25,000. Outlet C, gas range, 65,000 BTU per hour. Outlet D is 150,000 BTU per hour. Yung mga distance niya. So itong tawag dito, outlet A. Ito, outlet B yung pipe. So itong ano is section 1, 10 feet. Section 2, 10 feet din. Yan. So itong mga length na to, kasama na yung equivalent length dyan. So, sa actual, gagawa pa kayo ng fittings. Yung mga fittings doon, equivalent din. So ito, consider na kasama na magmula sa gas meter. Para lang tayo magkasample ng pipe sizing. Assignment nyo, dinagdagan ko to. So, kayo ba na kayo doon magsunod sa pattern. So, given piping system as shown, gas pipe sizes ang required. Solution, using table 9. Low pressure gas piping schedule, gas pressure, 0.5 PSI gauge, pressure drop 0.3 inch water column, based on 0.6 specific gas, gravity of gas. Now, ito yung procedure. Sulat nyo to. Kasi iba, pag nag-assignment na, nawawala na to, puro na numero nakikita. So, hindi pwede. So, sundan nyo yung step by step. Isulat nyo ulit ito. Huwag naman rin. Kahit paulit-ulit yan. Kasi nga, nag-aaral kayo niyan. Nag-aaralan nyo pa yan, kaya ulit-ulitin nyo. One, to determine the gas input of each appliances, use table or nameplate on appliance. So, already given na. Lagay na. Number two, determine the length of pipe from gas meter to its outlet. If length falls between lengths, lengths, should go to the next higher column. Basta yan. Yan, next higher column. 1, 2, 30, 10, 10. So, this plus 10 is 60 feet per meter. Ito naman 30, 10, 10, 55 feet per meter. So, ito naman 55 feet per meter. Then, so ito 40 feet per meter. So, eksakto doon, 40, 60, 70, di ba? Table. So, table 9. Table 9. Ayun, table 9. Ito. Yan, 40, 50, 60. So, walang 55. So, 60 ka. So, may 40 meron. Okay. So, yung sabi ko, ginamit ko rin ito. So, yan. Sa outlet A, yung 60 feet. Okay, exacto. Column demand. Load. We have na 30 cubic feet per hour. Paano nangyari yun? 30,000 BTU, divide mo ng 1,000. So, this is 30 cubic feet per hour. Okay. Ilan na ilagay niya. Tapos, 60 feet. Outlet B is 55. So, gamitin mo yung 60 feet. Ang demand niya is 25,000 BTU per hour divided by 25. 1,000 BTU per hour per cubic foot is 25 CFS. So, outlet C is 65, di ba? 65,000. So, total ng 40 feet ito, 30 plus 10 is 40, so 150. Yan. Pwede ng 1,000. So, pipe size. Sa outlet A muna tayo. Meron tayong 30 cubic feet per hour. Yung 60 feet. 60 feet. Ano yung 30? 30. Dito siya. So, gamit mo yung 50. Nalabas is 1 half. Yan. Nag-record ba? Next is outlet B, 60 feet, 25 CFS. Same, 60 and up, 25. So, 27. 27, about 25, so magiging 38. Okay. Pwede ka doon pag 1 up ka lang, hindi ka nag-decide. Decide is yung sumusunod sa table. Pero pag okay rin naman palakihin mo yung size mo lang. Pero hindi ka nag-decide. Wala ko yun. Hindi ka nakatipid. Nag-design ka para makatipid. Okay. So 60 feet, 65 CFS. 50 and 105. So dito ka sa 105, lalabas is 3/4. Diba? So 3/4. Yung 40 feet naman na 150, dito ko sa 40, hanapin ko yung 150, so 130 and 245. So dito ko sa 245, so lalabas sa is 1 inch. Yan. Yan ang pag-size. Kaya lang kung lalaro. Pag-aralan mo muna kasi iba naman laro ka di mo alam. So, figure the size of the main pipe feeding more than one appliance. So go to most remote outlet, it is 60 feet from the meter, so use 60 column. Then determine various pipe sizes based on demand load of each section. Section 1, if this is outlet A and outlet B, at mo magiging 55, diba? 30 plus 25 is 55 cubic feet per hour. So nothing being 55 using same column 60, 55, so ito sa 3/4. 105, repeat it to 50. So 3/4. Section 2, sa tatlo, ABC, so add mo itong tatlo, lalabas na rin is 120. So pipe size mo, 60 feet, 120 is 1 inch. So section 3, serves all outlet, lahat na siya. So total is 270. What is the pipe size? 270. Yan. 1 divide with the pwede, that's 400. So this is 1 and 1/4. Yan. So meron ka ng pipe size. This is now your final layout. So, sa final layout nyo, isusulat nyo lahat. Huwag yung 5 size lang. Ito, nagkawala to lahat. Wala. So, cross out ko yun lang. Hindi na wala na kung puro points. Kasi meron naman sample dito, gagayahin nyo lang kung ano ilalagay. After 4 days, yan, lahat yan ilalagay nyo kasi nga plano yan eh. Hindi mo pwedeng ilagay na 5 size to. Kung final layout no, walang 5 size, walang nakalagay kung anong equipment to. So, hindi yung plano. Okay? Yun yung final layout. So, final layout, may mga 5 size. Kadalasan kasi, nagsusubmit, wala yung mga 5. May computation, pero wala sa final layout. Yung final answer, no, wala. Okay? Hindi mo pwedeng ituro doon sa calculation, sir. Andun po yung 5 size. Sabi ko dito, layout. Kailangan mo ilagay yun sa layout mo. Kasi baka pwede kang magkamali ng turo. Di ba? Yan. So dito, apat to sa ano yung anim na yata yun. Pero baka same procedure. Okay? So ito yung reference natin. So this is the end of this topic.